Hello, this is a lesson 5.2 arc length and 5.3 areas of sectors and segments. So we're starting with 5.1 arc length, and when we're talking about arc length, what we're actually meaning for this is this length here. So it's part of the circumference of the circle, and this is the circumference of the circle, but this is when we were working at GCSE. I want us to look at this as if it was a GCSE style question to start with. And if we were doing arc length here, what we would say to ourselves is the arc length is a fraction or part of the circle, and the part of the circle would be the angle theta over 360, because that's what fraction of the arc we would have multiplied by pi d. So just going through that again, that fraction of the circle, because that's the angle theta of 360 multiplied by pi d. And therefore, that's in degrees. I want to do this now in radians. So I would still have my angle as theta, but my angle theta would now be in radians. So the 360 would also have to be in radians, and 360 degrees in radians is 2 pi, and then that would be multiplied by pi d. If I write that as one fraction, I would write that. And I can divide the numerator and the denominator by pi, and that would give me theta d divided by 2, which I could also write as theta multiplied by d over 2. Now the diameter divided by 2 is just the radius. So what I've worked out is that my length of my arc is my angle times my radius. I'm just going to recap that end bit again. Here I've divided by pi to get this. Using my knowledge of fractions, I know these are equivalent, and therefore, because diameter divided by 2 is the radius, I can write this. The final thing that you need to write down, learn, is L, which is your arc length, equals r theta. Notice we write it just the other way round. That needs to be written down. I would also write it in your formula book on a blank page at the back. And I've said this to students in the past, and you may already be filling that blank page up. That page at the back can have all the formulas in maths that you need that are not in your formula book, and you need to build up that list. I don't know what formulas that you don't know that you will need for your A-level. And when we get to the May time before the A-level exam, often I'm asked, what formulas do I need to know that aren't in the formula book? The area of a triangle, the area of a rectangle, the area of volume of a cylinder, the surface area of a cylinder. I can keep going for a very, very long while. But that list would become immense. And where do I start the list and where do I end it? And it's different for everyone. And because of that, you need to start making your own list now. So get that blank page there, get it filled in, have your formula book with you every lesson, and you need to start putting those key things in there. In statistics, there's some key things, again, that I think I often say to students, get those written down in there. So please put it in there and already start trying to learn it. If you're a revision card person, that needs to be on your revision cards. You need to know it. You won't be given it. I say that and then I pause. I say it because formula books change and rules change and things might change. They're not going to change for the 2021 exams, but if someone watches this in the future, it might be different then. So we're now going to use that to help us do some questions. So here, find the length of an arc. I do like a diagram with a circle of radius 5.2. And the angle at the centre is 0.8. It's in radians, which is good because we're working in radians. So this is really lovely and easy. L, the length of the arc, equals the radius, which is 5.2, multiplied by 0.8, and I type that in my calculator. So the answer is equal to 4.16 centimetres, and that's it. Really simple. Not a problem. I'm hoping for you to do that one. Copy it down, make sure you've got a good set of notes on that. Number 4, an arc AB of a circle. So we're back to our using our L equals R theta. An arc AB of a circle. So I'm going to draw a circle, and I've got an arc AB with centre O and radius R. Subtends an angle theta, so that's the angle that it turns through. Subtends, that's a word not to allow to scare you, but it's the angle that it passes through. The perimeter of the sector is P. Now, when it's talking the perimeter of the sector, be careful here. It's not saying the length of the arc. The perimeter of the sector is all the way there, all the way there, and all the way there. So my perimeter P is equal to R, add another radius, add my R theta. So my perimeter is equal to 2R plus R theta. Now it wants me to express R in terms of P and theta, so that means that it wants R equals. So to do that, I factorise out my R. Because I've got to get R on its own, at the moment it's in both terms. By factorising that common multiple out and putting it at the beginning of the brackets, I've now got R on its own, and so I can write R equals P divided by 2 add theta. And that there is the answer to that one. That's very much an A-level style question. The last one, not really, unless it was part of some workings to move on to the next stage. However, this here could be a nice little standalone couple of mark question. We're really starting to get to where a question could be at A-level. Right, next one. So make sure you, by the way, copied the last one down. Here's a wordy question. The border of a garden pond consists of a straight edge AB of length 2.4 and a curved part C as shown in the diagram. The curved part is an arc of a circle, centre O and radius 2. Find the length of C. Now, if we want to find C, that's the length of an arc, we know, because we write this, that we need to know the angle theta. And I don't know any angles at all. So I need to find what this angle here might be, which I'm going to call X. Now there's a couple of ways you could do that, and the reason, by the way, I can't think of a way of finding that angle there, but because I've got a lovely triangle here, that's why I'm thinking of finding that angle X. There's a couple of ways you could do this. So if I draw that triangle out, because it helps, and I would suggest you do sketch these things out when you're doing a question. This is 2.4, this is 2, this is 2. I can't assume this is a right angle triangle, so SOHCAHTOA can't be used immediately. So I could, because I have 3 sides, I could use the cosine rule. But I'm not going to, because that seems too difficult. And there is a way I can use SOHCAHTOA, because if I put a dotted line down here, I would create a right angle. And because I know it's an isosceles triangle, because this is 2 and this is 2, I know if I draw that line down there, it would divide this side in half equally. So I then could draw out a new triangle. That would be 2, this would be 1.2, and that there would be a right angle. Now remember, I can do that if you've never seen that done before, because it's an isosceles triangle, because I know it has symmetry, and that this would be a line of reflective symmetry. I know this length equals this length. So I'm using isosceles knowledge, rules of isosceles triangle knowledge, to help make this easier. Now this angle here will be what x over 2 is, because that's what that is. It's not going to be what x is, it's going to be half of x. So I've got the opposite and the hypotenuse, so the sine of x over 2 is equal to the opposite over the hypotenuse. So therefore x over 2, back to my calculator. So this is 0.64350111088. If you didn't get that answer, it might be because using your calculator in radians. Remember, it needs to be in radians. It also needs to be in radians for the last part. I should have said that. So radians is important because we are going to do arc length, and we're going to do all of it in radians. So therefore, I now need to work out what x is, that angle, and I just need to multiply my answer by 2. And my answer, 1.287002218. Now I'm writing everything down. I'm quite happy for you to round it a little bit when you're writing it down, but what I'm trying to get across here is I'm halfway through a question. I really should be writing down all of my, not writing down all of the decimal places, but using them in each calculation. So you should be using what's on your calculator, not necessarily what you're writing down, or you will build inaccuracies in, and that's how you can just lose 1 or 2 marks in exams. So make sure you're not rounding. So now going on, we now can work out what theta is, because that's obviously going to be 2 pi, because 2 pi, remember, is that full rotation of a circle. Subtract our value of x, and this will be our angle theta. So typing that again into our calculator, we get the answer 4.9961839, and we now can find out what C is, because C, I think I'll write this in a different colour so it stands out a bit more. C, remember, is the length of the arc, which is r theta. Let's write that there, because that's the thing we need to remember to use. Our radius is 2 multiplied by the angle, which we have there. So my answer, which I'm just going to have a look at what level of accuracy. So I think I'm going to go to 1 dp, because that's what they've been going to there. Well, looking at my answer, I've ended up with 9.99. It's going to make things difficult, so I'm going to just write 9.99 and do it to 2 dp meters. And I must remember my unit, obviously. And there's my solution for that question. Now, I would suggest at this point to go away and do some practice on the arc length. Once you've done that practice, then come back, listen to a little bit more and learn how to do the area of a sector. So we're now going to move on to area of a sector. An area of a sector, it's, if you think about it, we're talking about a fraction of the area of a circle. This is just like how I started the length of an arc. So if we're looking at the fraction of the area of a circle, the area of a sector will be the fraction, which will be the angle over 360, if we were doing it in degrees, that is, multiplied by pi r squared. But we're not working in degrees, are we? We're actually working in radians. So let's change that, and we can write this. And again, combining that into one fraction, because it makes it easier for us to see when we can divide the numerator and the denominator by the same amount, and we can divide both the numerator and the denominator by pi, and that would therefore give us theta r squared over 2. And how we actually write the area of a sector, because we did this with the length of an arc, what we actually do calculated and how it's generally written was slightly different, is that I'm going to write it in a different colour to make it stand out. Area of a sector equals half r squared theta, and you'll notice that is the same. They've just slightly altered the order, and rather than writing r squared theta divided by 2, they've just put the half and multiplied it. So that's what you need to learn. Again, already said about that formula book, having all those equations in there, get that in there on that page. And for the area of a sector, learn it, because you're going to need it to use it. Having done that, we then can move on and do some examples. So we need to remember that area, I'm just going to call it A, equals half r squared theta. That's the key thing for us to remember. So a plot of land is in the shape of a sector of a circle of radius 55 metres, and the length of the fencing that is erected along the edge of the plot to enclose the land is 176 metres. Calculate the area of land. So to calculate the area, I need the angle. I don't have the angle. What I do have is the perimeter. So the perimeter is made up of that 55 there, this arc length here, and the 55 there. So I could say that my perimeter is equal to 55 plus 55 again, because that's my two radiuses, plus my arc length, which is r, which is 55, times theta. I also know that equals 176, so I now can write 110, because 55 plus 55 is 110, add 55 theta equals 176. And because I'm fantastic at solving equations, I passed my GCSE well, I now can go on and I will get my value for theta as 1.2. So there's my value for theta now. So I now can go on and solve for the area. So my area would equal half multiplied by 55 multiplied by theta squared, and that would equal 39.6 meters squared. Okay, so that's more of a problem style one, and required multi-steps. Again, that's where A-level really is going to be. They're not just going to say to you find the area of a sector, because that might have been GCSE, but this is A-level. So yeah, I could see that. That would get you, say, 2 or 3 marks at A-level. I'm going to be honest, it's going to be one of the easier questions, but there are easy questions. There are easy and there are more difficult. But that's how it's more likely going to turn up, if it's going to turn up in a straightforward format. So let's now look at our next example. Right, something a little bit more complex. So in the diagram, AB is the diameter of the circle of radius r. So you can see here r from there to there, r from there to there. And angle BOC is theta radians. Given the area of AOC is 3 times that of the shaded segment. Now, we haven't dealt with segments before, so I just want to go off and explain them. A segment is this part here. And the key thing to realise when you're dealing with this is you need to find the area of the sector and then take away the area of this triangle. So it's the area of the sector, take away the area of the triangle. I'll write that down. So area of segment equals the area of the sector, subtract the area of the triangle. I know it's written a bit oddly, but I think it's really to get that into your mind, how you would work that slither out. So we also need to, because it's saying given the area of AOC, is the area, and I'm going to shade it in on this diagram, of that bit there. That's what we've got to say. And we want to, we're told that that area is 3 times the area of the segment. So let's find the area of the segment to start with. We might as well start somewhere. So area of the segment is equal to the area of the sector, which is half r squared theta, minus the area of the triangle. Now you're going to think, oh, how do I find the area of a triangle? Well, this goes back to sine rule, cosine rule, and half AB sine C, because I can use on this the formula of half AB sine C, because if I draw on this triangle here, that's theta, and if I label it A, B, C, and this is R, and my formula for the area of a triangle is half little a, little b, sine C. Well, my little a and my little b, they are going to be R, and my sine C is going to be therefore theta. So minus half A, B, sine theta. Now you might want to pause and just go back over and check that you understand how I've got that again, because that's linking back. You may not have used that since last year or even GCSE. that you remember that half AB sine C, and that the capitals are your angles and the lowercase letters are the sides. So tidying that up, which we always need to do, we're going to write that's equal to half r squared theta minus half r squared sine theta. I don't know whether this is going to be any use at the moment, I honestly don't, but because I've got a common factor there, I am going to write that, because it sometimes will help me at the end. Might not help me at all. We'll see. So that's the area of the sector. I'm going to underline that, or even put it in a box. And the reason I do that, when I get to the end of a question, and I'm halfway through a question in this case, it's really important that I find the correct bit when I'm working through. So the next thing I need to do is find the area of this. Well, this is a triangle again, and the bit you need to spot is this is an isosceles triangle because this side here is R, and because this is the centre going to the circumference, this side here is also R. This angle here is 180 minus theta. So I'm going to actually shrink it a bit to give myself some space over here. And I'm going to draw a line. So the area of the triangle equals half AB, A times B, multiplied by, I'm going to have to squeeze this in, or can I move? Yes, I can move a little bit. Multiplied by the sine of 180 minus theta. Now I've just done something quite daft there, because I wouldn't write 180 minus theta because I'm working in radians. So you see, we can all forget what we're doing. So I'm going to do it correctly, and it's the sine of pi subtract theta, because remember 180 degrees is pi. Now let's look at pi minus theta, because that's where I think some of you may get stuck, and I need to just draw the sine graph, and there we go. I'm just going to start it there because I'm going to start it at 0. Obviously it does come back here. If we are saying that our value of theta is less than 90 degrees as represented on the diagram, well, that 90 degrees is pi over 2, so that means if this is pi and this is 0, if I draw my value on anywhere here, whatever that value is, so that's my angle there, if I take that same angle away from pi, so I'm taking it away that little bit, you'll notice I end up at the same point, because the sine of theta is equal to the sine of pi subtract theta, because these two values are the same. It only happens in that area of the graph. Remember, this is only something special about sine there. And I bet you're thinking, well, how would I know that in the exam? And that's where you've really got to love your graphs. I know you don't like your graphs, or maybe you've got there with them. I didn't like the graphs when I was an A-level student, and now, because I've pushed myself, because I've done it so often, I now love graphs. So if you're not loving them, the more you draw them, the more you push yourself into that uncomfortable zone, the bigger your understanding grows, and then actually you will go to graphs all the time. As soon as I looked at this, I was like, oh, need a graph, need to think this through. So you can see that, and by the way, this will happen for any value. So if I choose a different one, it's a bit of a small diagram. I'll get a black pen. If I go for this here and I go for that bit there, If I do the same here, you're going to end up with, again, the same value because of the beautiful symmetry between naught and pi that takes place. So that's something you may, again, it might be something to write in your formula book and draw a little graph just as a bit of a or a little revision card on that, just so you know, because if I'm honest, this is the difference between a student who's going to do B grade and above and a student who's going below that B grade. Because it's that depth of understanding that they test for the B and the A. Therefore, because these are the same, I now can go back and I can write that this is equal to half r squared sine theta. And so that there, let me draw it in a pink circle, has changed to that there because the sine of pi subtract theta is the same as the sine of theta. So now this is the area of the segment and this is the area of the triangle here in pink. Now I need to read what was I actually asked to do. So given the area of AOC, this pink triangle is 3 times that of the shaded segment, show that. So we're saying that the area of this is 3 times the area of that. Right, so we're saying the area of my triangle is equal to 3 lots of that. So I can immediately see that I can do some dividing. So I can divide both sides by a half. I can divide both sides by r squared. So I would then end up with sine theta equals 3 of theta subtract sine theta. And what format have I got to get it into? I've got to get it into that format. I'm running out of space wherever I go, I seem to be. So I'm going to come over here. And so I'm going to take this line here. So I'm going to put a box around it so you can see. This is where being in the classroom is so much easier. So here, I'm just going to write this line out again so that it's not too confusing, my moving around on the page. I can then multiply out my bracket and then from there, just looking back, I want to take this sine theta, take a sine theta from both sides. So 3 theta minus now 4 sine theta equals 0, which is the answer. And the last part is just a bit of rearranging. So it's important, just gone off of that page, it's important that first of all we say that is 3 lots of that. Then we've divided both sides by half r squared theta, by just half r squared to get this. Expanded my bracket and then subtracted sine theta from both sides, and therefore I would just have 0 this side, or as I've swapped it round and writing 0 there. And that's what the actual answer is. I very, very much, that is an absolute A-level question. No doubt it would get quite a few marks. It could come up anywhere in the paper. But that's how they would get it to a higher level standard rather than it being part of a question. That would quite happily stand alone. Okay, so now really you just need to do some practice on finding the area of sectors and segments.